I've given you them before. So this is compound interest, and this is a continuously compounded interest. We'll show how we get that tomorrow. But let's go to the first question. It says, radioactive substance decays in such a way that the amount of mass remaining after t days is given by the function m of t equals 23 e to the negative 0.0443 t, where m of t is measured in kilograms. Find the initial mass. So, you tell me, initial mass is how much the material weighs at the very beginning. So if I want to know at the very beginning, what time should I plug in? Time 0. Very good. So we're wondering at time equal to 0. So let's plug in t. I'm sorry, let's plug in 0 for t. So m of 0 is equal to 23e negative 0.0043 times 0. What is negative 0.0043 times 0? 0. And what is e to the 0 power? Anything to the 0 power is 1. So you end up with 23 times 1, which is 23. So the initial mass is 23 kilograms. That's what it starts at, which is right around 50 pounds. Okay, you got 50 pounds of radioactive material. Oh no, look, right? Danger. We're wondering, when is it going to go away? It does decay. It decays rather slowly, but it does decay. So the question is, how much mass remains after 21 days? How will I calculate that? Plug in 21. And we have m of 21 is equal to 23 times e to the negative 0.0043 times 21. Now the reason why I'm writing this out is I want you to understand how we plug it into our calculators as well. So as I turn my calculator on, 23, and then your e to the power is your second natural logarithm button. So second natural log. So I got e to the, and then you got to make sure you put everything up there in parentheses. So we've got that parentheses, negative 0.0043 times 21. That way you have everything multiplied in the exponent. Press enter, and we get 21.01. So after 21 days, you've lost a little bit of the material, but not a ton. You got 21.01 kilograms. Any questions how I got A or B? Okay, in question C, after how many days does it have a mass half the initial mass? Ooh boy, that sounds a little bit more complicated. What do I do? What's half the initial mass? 11.5, very good. 11.5 is half the initial mass. So that's our mass, and that's going to be equal to our equation, 23e to the negative 0.0043. Do we know t? No, we're trying to solve for t. It says how many days. So we're trying to solve for that time variable. Look at what you have. What kind of equation is this? It's an exponential equation. And what do we use to solve exponential equations? Logarithms. Very good. What do you do to start solving this? Divide by 23 first. Divide by 23. We know 11 and a half divided by 23. It's a half. So you got 1/2 is equal to e to the negative 0.0043 t. If I want to get to the t, what do I have to get rid of? The e. How do I get rid of a base e? Natural log of both sides. So natural log of 1/2 equals natural log of e to the negative 0.0043 t. What goes away on the right-hand side? Natural log in e and leaves you with negative 0.0043 t. How about the left-hand side? Can you take the natural log of 1/2? You can. And on your calculator, take the natural log of 1/2 and you get negative 0.69. How do we solve that equation? Very good. We divide negative 0.0043. and you get 161.2 days. So it takes 161 days to be half the size it started. So can you see why logarithms were valuable in this problem? Are you going to encounter situations in your life where you deal with exponential equations? You will. You know why? Because all of you will invest money and all of you will own a home. And so you'll take out a mortgage. So whether it be you're investing money or borrowing money, that's something you have to be leery of. I was at the bank not too long ago, and I asked for the right type of loan that would save me the most money. They didn't know how to do the math, and they told me what I should buy. I said, I'll go home, check it out. I came back, and I said, I don't want to sound like smarty pants here, but I said, I'm a math teacher. I said, I'm sorry, but you did your math wrong. I said that this other loan would be better. And she's, do you even know the quadratic formula? No. And they said, yeah, you're absolutely right. They said, you're right, we made that mistake. Sorry about that. You'll be at an advantage if you can look at things and understand them in this context. So we pick up with the rest of it tomorrow, and tomorrow you'll get an assignment.